Hi there, and thank you for clicking on this video. In this video, we are going to work through some practice problems on simplifying radicals. Like and subscribe if you find this practice set helpful, drop a comment or a question, and check out the many other videos and playlists that are on the channel. As always, pause the video to work these problems on your own, and then come back to check your work. The directions are to simplify each radical completely, and just because of my day job, I'm going to reiterate, practice them on your own. That is the point, to see how well you understood what we covered in the lesson and to kind of quiz yourself and make corrections and generate questions, which of course you can ask your teacher or ask in the comments to this video. Okay, so these do vary in difficulty, and they don't necessarily go from easiest to hardest or anything. I did try to get a variety of different kinds of simplification of radicals problems. So the first one is a square root, and you can really simplify this any way you want. The first way you might think to do it, and this would be completely correct, is to recognize that 16 was a factor of 32, and then do the square root of 16 is 4, and so that simplifies to 4 root 2. Okay, so that would be how you might have been taught to simplify that in Algebra 1. Now, in the lesson video for this topic, I went through a strategy called the prime factorization. So I do want you to see how that strategy applies, even if you simplified it this way. So with prime factorization, you would take the 32 and you would break it into factors. So you might say 32 is 4 times 8. And then you look at the 4 times 8 and you say, okay, the 4 factors into 2 times 2. And then 8 factors into 2 times 4. And then you want to remember those prime numbers once you get them. And then 4 factors into 2 times 2 again. So what you end up with is 2 times 2 times 2 times 2 times 2. And so the other way you can do that is you factor it into the prime factorization. So we have 5 2's there. And then you look for the perfect squares, okay? And so you look for 2 squared and 2 squared. So we've got 2 squared and 2 squared. And then the square root of 2 squared, well, that would be a 2. And then the square root of the other 2 squared is another 2. And then still hiding out under the square root is the remaining 2, and then 2 times 2 is 4. Now, this way does take longer. So when I personally am simplifying the square root of 32, I'm going to do it the first way. What I like about the second way is a couple of things. It really reviews what the radical does. So it entrenches the operational nature of the radical in your head. The other thing it will do is it will avoid you possibly stopping halfway through. So a common mistake to make on this would be to recognize the 4 times 8, take the square root of 4, and then leave it there. Now, is that simpler? Yes, because 8 is smaller than 32. Is it simplified completely? No, because you could get a smaller number. So if you go the prime factorization route, you are less likely to end up partway. Now, you can finish it from here. Okay, you can recognize that 8 is 2 times 4, and then take the square root of 4 and get the other 2. Okay, so you can get there, but a lot of students will make the mistake of stopping at the 2 root 8, figuring that they got the perfect square. You got a perfect square factor. You just didn't get the biggest perfect square factor. So you left something underneath. So a couple of things that are advantageous about using the prime factorization method. But as I said at the beginning, you can do that any way you like, any of those 3 methods, as long as you land at 4 root 2 and you understand how you got there. Okay, so next one is the cube root of 192. So I'm super thrilled with the 192. I'm not really. I did go grab a calculator, but now I don't feel like using it. So I need to factor the 192. Okay, so now here's what I know. I know that that's an even number. So I'm going to go ahead and divide that out. And so I get 2 times 96. 96 is also divisible by 2. So that's 4, 16, so 48. Okay. And now I'm down to stuff that I'm a little bit more comfortable with. What is that? That is, we'll do 8 times 6. Loving this. And then I'm going to take like a little bit of a shortcut. I know that 8 is 2 times 2 times 2. And I kind of just did that right here. Okay, if you look over to the left, where 8 factors into 2 times 2 times 2, and then 6 is 2 times 3. So that number, as much as I love that, is 1, 2, 3, 4, 5, 6 2s. 1, 2, 3, 4, 5, 6, and a 3. Love it. Okay, now this is a cube root. So if it's a cube root, it's going to undo cubing. So right here, I see a 2 to the 3rd power. And then I see another 2 to the 3rd power. And if you don't remember from the video, the cube root of 2 to the 3rd power is 2. And so each of those generates a 2 for me outside. And so we left with the cube root of 3. That's what I didn't grab. And 2 times 2 is 4. So the hardest part of that, honestly, was this whole mess of stuff. It was taking that 192 and just like grinding it out. And then I'm, of course, being stubborn and I don't want to go get a calculator. So I am just doing the long division out because easier for me. All right. So on to the next. So now we get to some smaller numbers. So I am thankful for 15s and 16s. And we have the variables thrown in there as well. So let's like make sure we're paying attention to that. So for the cube root of 15, x to the 5th, y to the 6th, 15 is nice because it only factors into 3 times 5. And you might, like, just from the very beginning say, hey, that's just 3 times 5. Like, I don't have 3 times 3 times 3. I don't have 5 times 5 times 5. Like, that's not there. The number is too small. And so you might say, I'm not even going to pull apart the 15 into 3 times 5 because I know that there's nothing in there. Common mistake, though, is for people to do 15 divided by 3 and tell me that the cube root of 15 is 5. It is not. 5 would be 15 divided by 3, not the cube root of 3. Okay, and so now we have 5 x's and we have 6 y's. So we kind of like cringe at how long that gets. And now we're looking for groups of 3. So I've got, here's a group of 3. So there's an x cubed that my cube root will undo. Here's a y cubed. And here is a y cubed. So coming on the outside, the cube root of x cubed is x. I've got a y, I have another y, and then underneath my cube root, we can put this back together again. I have 3 times 5, which is 15, and x times x, which is x squared. And of course, on the outside, that'll be 3xy squared. And then the cube root of 15x squared. So there we go. Ta-da. Beautiful. Okay, now for the next one, we want to be wary. This is an even powered root, so this is where you might end up with the absolute values coming into play because we want to be careful about that x to the 8th. We'll have to see what comes out, but if there's any chance that what comes out could be negative, we will need to put parentheses around it. So let's go ahead and take care of that. So we have 16 x to the 8th. 16 is 2 times 8, and as I mentioned, that's 2 times 2 times 2. And notice just how quickly you get at that. If you are constantly doing that prime factorization and you're getting plenty of practice, you're going to get really, really, really good at this. Okay. All right. So we're going to have 4 and 2, so 2 times 2 times 2 times 2, and then 8 x's. What was I thinking when I wrote this problem? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And we are looking for groups of 4. So we've got, here we have a 2 to the 4th. and then we have an x to the fourth, and then we have another x to the fourth. So the fourth root of 2 to the fourth is 2. And then we have the fourth root of x to the fourth is x, and then another one is x, and of course x times x is x squared, and there's nothing left under our radical. Now, do we need to put parentheses around any of this? No. The 2 is positive because I wrote it as a positive 2, just like if it were the square root of 36, like I would just write 6. And I don't need to worry about the x squared being negative because x squared isn't negative. So whatever x squared is, even if x is a negative number, when I square it, I will get a positive, and so the answer to this will be positive no matter what. Okay, unless x is 0. Okay, we won't touch that. But all right, so that one we don't need to worry about the absolute values. Now this next one, this one you might be like, wait, why did she do that? Is there a trick to this one? Not at all. The square root of 16 is 4. And the reason I put that in there is because I've seen so many students do stuff like this. So I'm going to label this like I did in the video as error. Okay, so don't write this down. They'll do the square root of 16 is equal to the square root of 4 is equal to square root of 2 is equal to 2 or something like that. Like, so there's like kind of this weird chain of like work that's wrong. And again, the puzzling part is that if I ask a student, what is the square root of 16? I will most of the time get the verbal answer 4, and then the student will write down the square root of 4 and then get confused and be like, oh, I guess I should do it again, and end up like carrying on the problem. Square root of 16 is just 4, like literally just the 4. All right, for 6, we have the square root of 12x to the third, y to the fifth. We'll do a little bit of work over here with the 12 factors into 3 times 4, and then the 4 factors into 2 times 2. So here we'll have 3 times 2 times 2. We will have x to the third, and then y to the fifth. And this is a square root, so the implied index is 2. And so we're going to be looking for things that are squared. So there we have 2 squared. I have an x squared, and then I have a couple of y squareds out here. Okay, and the square root of 2 squared is 2. The square root of x squared is x. And at this point, like if you've been doing these, like you know you're going to have a y, and then you're going to have another y. So if you want to go right to that's going to be y squared, knock yourself out. And then still left under the square root, we have a 3, we have an x, and we have a y. Now, this is an even powered root, so we do need to do that check to see, hey, is there anything that might possibly be negative here? And yep, we have we have the x. Okay, so the 2 is not negative. I don't need to worry about the y squared being negative, but the x could potentially be a negative value, and so we're going to make sure we get those absolute values around the x. Now, if your teacher is not, like if your teacher did not touch the absolute value piece, like don't worry about it. You make this video work for you and for your classroom. Listen to what your teacher said. So if you wrote 2xy squared and you know your teacher's going to give you 100% credit for that, don't worry about it, but you just kind of, hey, just remember that this is a thing. Okay, next one, we have the cube root of 48x to the fourth, y to the third. So let's go ahead and take a peek at that. So we're going to do our prime factorization. So 48, I look at that and I see, actually the first thing I saw was 24 times 2. Not sure why I went that route instead of 8 times 6, but all right, let's just keep with the 2's. So we've got 2, 2, and then a 2 and a 6. And so we'll have 2, 2, 2, and then a 3. I feel like we could have gotten there faster, but maybe not. All right, so we've got our long prime factorization. So 2 times 2 times 2 times 2 times 3. times x times x times x times x and times y times y times y, and we have a cube root. So we're going to be looking for groups of 3. There's one. Here's one with my x's, and here's one with the y's. The cube root of 2 cubed is 2. The cube root of x cubed is x, and the cube root of y cubed is y. Still hanging out under my cube root is the 2. Oh, wait a minute. It is a 2, but it's a 2 times a 3. So usually I try to group those so they're next to each other, and I didn't. So there you go. So it's 2 times 3, which is 6. And then we have the x. And then I almost left out the cube root. So there we go. And with these, it is okay if you are taking the cube root of a negative. So you don't need to worry about a cube root with the negatives. Now for 8 is intentionally just decided. Actually, you know, the true story, I got bored writing them and I thought, I don't want to keep doing these kind of problems. I'm bored. Like, what can we do to change it up? So in this one, we have the square root of x squared, and the squaring will undo the square root, leaving us with the 2x. Now, when I was like thinking about that, I thought, do we need to worry about the absolute value here? The square root of 2x and then taking that value, whatever that is, and squaring it. And my hot take was no. And here's my reasoning. Now, this is a perfect opportunity for, say, a comment if you think I did this wrong. So let's just say we have like the square root of the negative. So we have a -4, okay? And we're going to square that. And I want to know, like, is it okay if the answer to that is actually -4, like where I don't worry about whether or not the value is negative. So what I did was I did it out. So the square root of -4 is 2i. Okay, and so it would be 2i squared, so that's assuming it is negative. So 2i squared would be 2i times 2i, which is, of course, is 2 times 2 times I, which is 4, and then I squared is -1, and you get -4, and that actually would be the answer. So even if the x value is negative, in that case, like, you would get the negative out. If you took the square root. So there you go. That was my reasoning. If you think my reasoning is wrong, if you think it's wrong, let me know in the comments. We can hash it out and see where it goes. Okay, next one was the 5th root of 4 raised to the 5th power. And again, what we're driving at here is that the 5th root and the 5th thing undo each other, leaving you with the 4. Okay, so they are what we call inverse operations. And the last one, frankly, I, again, was kind of getting bored. And for some absurd reason, I made these like really large exponents, but I wanted to throw in a z. Now, as you do these, what should happen is you begin to notice patterns. And so you realize, hey, I don't actually need to expand out like 8 z's. Okay, like I don't need to do it, because what I know I'm going to do is I'm going to find a group of 5 and pull it out, and I will have 3 left. Okay, so reasoning it that way, you got your to the 5th power. Actually made that too big. Let's try that again. So you got your to the 5th power. All right, and you look at your x's, and so you're picturing in your head 6 x's, x, you know, done out 6 times, and you circle the group of 5, okay, and you pull out the group of 5, and you've got 1 left over because you had 6. And then you can do the same thing with the 7s. You picture 7 of them done out. You're going to circle 5 of them, and those are going to come out as a y, but because there's 7, you actually have 2 left over. And then you do the same thing with the z's. You have 8 of them. You're going to circle 5 of them because you're looking for that group of 5. That group of 5 comes out. and you are left with 3 of them. And you can do it that way. So it is possible. I don't encourage you to do that until you are reliably getting things right. So if you're like, hold up, you totally lost me on that. 2, 3, 4, 5, 6. This is what I just described. Okay, 4, 5, 6, 7. And then we have 1, 2, 3, 4, 5, 6, 7, 8. And you come through and say, all right, I've got 6. I circled a group of 5. I've got 7. I circled a group of 5. And I've got 8, and I circled a group of 5. So coming out of the radical, I have 1x, 1y, and 1z. And what I'm left with is 1x, 2 y's, and 3 z's. Okay, now, I am, again, if you've followed my videos, you know that I am not somebody who's like big on shortcuts. This method of doing the prime factorization is really rock solid. As you get practice with it, you will begin to notice things like that, and you will begin to do the problems quicker with skipping some of the steps. Always, always, always follow your teacher's directions for how you are supposed to show your work. If your teacher is requiring you to show work in the middle of it, like, make sure you're showing work. But what's good about that is you are coming up with a shortcut based on your understanding of the math, not using a shortcut that somebody showed you and you have absolutely no idea what it is about. All right, as always, please don't forget, like this video and subscribe to the channel if you found this video helpful. Drop a comment or a question below if you want to make an argument for that. I like the absolute values. By all means, make a comment. Let's hash it out. Let's talk about it. And check out the many other videos and playlists on the channel. We've got lots of playlists for a lot of different math content, and I hope that you can find it helpful, and I hope that I see you in a future video.